Hi friends, now second video, factor affecting bendability. Factor affecting bendability. Friends, in my first video you see if R by T ratio approaches to 0, then it is known as complete bendability. Friends, the material can be folded. It means the material can be folded over itself like a piece of paper at a tensile reduction of area of 50%. This percentage is perhaps equal to obtain for spinability of material. That is, a material with 50% reduction of area is found to be complete spinable. Friends, so relation between R by T and percentage reduction of area is shown in the graph. Friends, in this graph, R by T ratio y direction shows and x axis shows tensile reduction of area in percentage. X axis, and this is R by T y axis. So friends, you see in this graph, if tensile reduction of area is increases, then R by T ratio is also decreases. If you draw a lone graph, then you see, friends, if R by T value as like high, then this is 0, 5, 10, 20, 10, 20, 5, 10, 20, 10, 20, 30, 40, like this. This is a percentage reduction of area and this is R by T ratio. So if R by T ratio is high, then percentage reduction area is less. If this is decreases, then percentage reduction of area is also increases, like this. And if R by T ratio is equals to 0, if R by T ratio equals to 0, then this, it is known as 100% bendability. That means if R by T equals to 0, then it is known as complete bendability. It means if this is a sheet, then this sheet can be bent like this, totally bended. If this percentage area reaches as 50%, then it is known as complete spinable. Friends, factor affecting bendability we discuss. If the bendability of metal be increases by increasing the tensile reduction of area. If tensile reduction area is increases, then bendability is also increases. You show in the further graph. In this graph, this increases, then bendability also increases. So, and this process is happen by heating or by hydrostatic pressure. This bendability can be achieved by heating of material or hydrostatic pressure. So what is this? We discuss here, friend. If this material having in one direction pressure, then it is known as uniaxial pressure. If this metal having two different faces pressure, then it is biaxial. Here 2p direction shows. And if this metal having all faces having their pressure, then it is known as a hydrostatic pressure. That means equally, this metal having equally pressure in all around, all faces. Friends, other technique may also use to alter the stress environment during a bending operation, such as you apply compressive force in the plane of the sheet during bending to minimize tensile stresses in the outer fiber of the bend area. Okay, as the length of the bend increases, you show in my first video, increases, the state of state at the outer fiber changing from uniaxial stress to biaxial stress. The reason for this change is that the bend length L tends to become smaller. Tends to smaller due to stretching of the outer fiber, as in bending a rectangular eraser, but it is constrained by the material around the bend area. Friends, biaxial stretching tends to reduce ductility. Biaxial stretching tends to reduce ductility. Ductility is tend to fracture. Thus, as L increases, the minimum bend radius increases. Okay, L increases, the minimum bend radius increases. However, at a bend length of about 10t, if bend length reaches about 10t, the minimum bend radius increases no further. That means, friends, this theory this theory tells about that if L is reaches 10t, then R mean no further increases for the plane strain condition. Plane strain condition. Okay. It means if L reaches 10t, then R mean no further increases, and this happen plane strain condition is fully developed. In this condition, plane strain fully developed. As R by T ratio decreases, that means smaller the bend length, L is less, then it begins to crack at the edge and wider sheet crack at the center where the biaxial stresses is higher. Friends, bendability also depend on the edge conditions of the sheet being bent. Okay, because this is a rough edge. Rough edge have various location of stress concentration, because rough edge having various location of stress concentration, and bendability decreases as roughness increases. If roughness increases, then bendability decreases, because rough edge having more stress concentration. Another important factor is that amount of cold working that the edge undergo during shearing, as can be observed from micro hardness test in the sheared region. Removal of cold work regions such as by saving machining annealing greatly improve the resistance to edge cracking during bending. Friend, this figure shows this is a plane strain, this is a plane stress. Okay, and if this is a smooth edge, this is a rough edge. If rough edge increase, then bendability decrease, because here stress concentration is increases. Now friends, in third video we will discuss about spring back. What is spring back in bending? In bending we discuss spring back.